Hello everyone. Today we'll be dealing with three-phase induction motor, which is the second chapter of Module 5. So this is a picture of a three-phase induction motor. Again, the three-phase induction motor consists of two parts, stator and rotor. So this is your stator part, which is the outermost cover. Rotor is the rotating part of the machine. This is the shaft. So the rotor is placed on this shaft. This is the drive end, this is the non-drive end, wherein the drive end can be any load. You have some ducts on the stator frame for the cooling purpose, and we have three tumbles over here to supply AC so that we can generate some constant flux. We'll see this for the next topic. Contents to be covered in this session are electrical machines, introduction to three-phase motor, construction of stator rotor, and working principle. Now, what is an electrical machine? An electrical machine is a device which converts mechanical energy to electrical energy or electrical energy to mechanical energy. So in synchronous generator, we have seen that alternator is a machine which generates three-phase voltage. Again, alternator and the generator are the same, but in generator, it converts mechanical to electrical by the means of prime mover into AC or DC. But alternator, again, it converts mechanical to electrical by the means of prime mover to AC only. Here, transformer is also a machine which includes under electrical machine, but it does not convert mechanical to electrical or electrical to mechanical. It's a static device. They convert AC current from one voltage level to another voltage level. We have AC generators also, we have DC generator. AC generator which converts mechanical to AC current. We have DC generator which converts mechanical to direct current. Electric motor. Electric motor is a machine which converts electrical energy to mechanical energy. An example could be your water pump. So you're trying to pump the water from the ground level to the upper tank. So here you are switching on the supply. The motor will try to pick some water or drive the water and force it to the upper tank. So you are converting electrical energy to mechanical energy. You are making the motor to work as a mechanical energy. So here it works on the principle that whenever a current carrying conductor is placed in magnetic field, the conductor experiences a mechanical force. Just like a synchronous generator or a generator, motor also consists of two basic parts, stator and rotor. Right. Now, classification of AC and DC motors. AC motors, we have induction motor and synchronous motor. DC motors, we have brushed DC motor and brushless DC motor. So again, when you look at the principle of DC motor, when a current carrying conductor is placed in magnetic field, it experiences a mechanical force or there is a torque produced in that particular conductor. So the direction of the force is given by Fleming's left hand rule, and its magnitude is given by F is equal to BIL, where B represents the magnetic flux density, I is the current, and L is the length of the conductor. Right. So the Fleming's left hand rule helps in understanding the direction of force experienced by the current carrying conductor. Right. So let's see how it's going to work. Fleming's left hand rule. If you stretch the three fingers, right, the thumb represents the direction of force, the forefinger represents the direction of magnetic field, the middle finger represents the direction of current. So as the field is moving from north to south, the current is coming out of the conductor and it makes the conductor to move upward. That is the force which is been given on the conductor. Right. Introduction to induction motor. A three-phase induction motor runs on a three-phase AC supply. It is most extensively used for various industrial applications, having following advantages. They are very simple and rugged construction. It's very reliable and having low cost, high efficiency and good power factor. It has minimum maintenance required. They are self-starting machine. Following disadvantages are the speed is going to decrease with the increase in load. If the speed is to be varied, we have to sacrifice the efficiency of its machine. Now we'll be looking at the construction of a three-phase induction motor. Basically, there are two types of three-phase induction motor. Right? First one is squirrel cage induction motor. Second is phase wound induction motor, which is also called as slip ring induction motor. Both the types have similar constructed rotor, but they are going to differ in construction. Construction of stator. This is the construction of stator wherein this is the lifting eye, this is the steel frame, we have stator slots, stator core and the base plate. The stator is cylindrical in structure. Stator consists of a stator frame which is made up of silicon steel, which forms the outermost cover of the motor. Now the function of stator frame is to support the stator core and protect the inner parts of the machine. Now the stator core is made up of thin laminations of silicon steel. Its function is to carry alternating flux, which reduces the eddy current loss and hysteresis loss. Now on the inner periphery of the stator core, uniform slots are cut, and in these slots stator conductors are placed. These conductors are connected as a balanced three-phase star or delta winding. When a three-phase supply is given to the stator conductors or the winding, due to which a constant magnetic flux is produced in the stator, which is going to revolve at a synchronous speed. This rotating magnetic field which is produced in the stator is responsible to produce the torque in the rotor, which rotates at on its own RPM. Right? So when you look at this picture, again this is the stator frame. The outer side is the stator frame. We have three terminals coming out of this stator windings, and to these stator winding will be supplying three-phase supply, so that there will be a constant flux which is produced in the stator, which is going to revolve at synchronous speed. Right? Now again you can see one more picture. This is the outer frame. We have stator slots and we have windings. Again this is the same picture wherein the windings are placed in the stator core. Right? This is the so when a three-phase supply is given to the stator, a constant flux is produced which is going to rotate at synchronous speed, and that rotating magnetic field is responsible to rotate the rotor on its own RPM. And the relation is given by Ns is equal to 120F upon P. F is frequency of the supply, Ns is the synchronous speed, P is the number of poles. Rotor. Rotor is the rotating part of induction motor, which is mounted on the shaft, to which any mechanical load can be connected. There are two types of rotor: squirrel cage rotor and phase wound rotor. squirrel cage rotor. The rotor is again cylindrical in shape. Most of the induction motor, up to 90%, are of squirrel cage type rotor because of its simplicity and rugged construction. Now, it consists of parallel slots on its periphery. You can see that there are parallel slots on its periphery, and in these slots we are going to place the rotor conductors. The rotor conductors, like copper or aluminum bar, is placed in each of the slots. Now all the bars are welded at both the edge of metal ring called as end rings, which forms a permanent short circuit. Hence, it is not possible to add any external resistance in series to the circuit. Thus, this rotor construction looks like a squirrel cage. Following are the advantages of squirrel cage. The gauge rotor is cheaper and the construction is robust. The absence of the brushes reduces the risk of sparking. Its maintenance is less. The power factor is higher, and also the efficiency of the gauge rotor is higher. We'll be looking at phase wound rotor. It consists of a laminated cylindrical core having uniform slots on its periphery. It carries a three-phase winding in star connected, which is placed in these slots. The open ends of the star winding are brought out, connected to the slip rings, which are mounted on the shaft with one brush resting on each of the slip rings. Now the three brushes are externally connected to a three-phase star rheostat, which is used as a starter during the starting period. This arrangement is done to introduce an external resistance in the rotor circuit for starting purpose and for changing the speed torque characteristic. So this is the explanation. Advantages of phase wound rotor are high starting torque and low starting current for controlling the speed of the motor, and external resistance can be added in the circuit. Let's look at the working principle of three-phase induction motor. The outermost cover is the stator part. The inner part is nothing but your rotor. Now on the stator we have three-phase windings, and to these three-phase windings we are going to supply three-phase supply. So when a three-phase supply is given to the stator winding, the constant magnetic flux is produced, which is going to rotate at a synchronous speed. Now this rotating magnetic field is going to sweep across the rotor conductor, and an EMF is going to be induced to the rotor conductor. As the rotor conductors are short circuited, there will be a current flowing in the rotor also. So when a current carrying conductor is placed in the magnetic field, it will experience a force due to which the rotor produces a torque and which will rotate in the same direction as the rotating magnetic field. It is all due to the relative motion between the rotating field and the stationary rotor conductors. Here the rotor gradually increases its speed and tries to catch up the speed of the RMF, but it fails. If the rotor tries to catch the speed of the RMF, then the relative speed between the rotor and the synchronous speed will be 0. Hence, no EMF will be induced in the conductor. So the rotor will be always rotating less speed compared to the RMF speed, that is synchronous speed of the magnetic field. So this is the explanation of the working principle, right? The difference between the synchronous speed ns, that is the speed of the rotating magnetic field, and the actual speed of the rotor n is called as slip speed. Therefore, slip speed is equal to ns minus n. The slip of induction motor is defined as the ratio of the slip speed to the synchronous speed. In terms of percentage, it is ns minus n divided by ns into 100. Thank you. So these are the links where you can go through and understand the working principle of three-phase induction motor.